The last section of chapter 10 and for the year is geometric sequences and series. So just as a quick review, up here at the top, a geometric sequence. Remember that a geometric sequence is any sequence that is formed by multiplying the previous term by the same number. And remember that that number is called the common ratio, which we refer to as lowercase r. So this example here, are each of the following geometric sequences geometric? Are each of the following sequences geometric? If so, give the first term and the common ratio. So 3, 6, 12, 24, 48, are they being multiplied by the same number? We're multiplying by 2. So the first term, remember written like this, would be 3, and my common ratio would be 2. Okay? Let's look at this next one. So 3 to 6 would be multiplying by 2. 6 to 9, you can't multiply 2, right? These are all like we're adding. The pattern here is adding 3. We know that addition is not a geometric sequence. Instead, this would be an example of an arithmetic sequence. And then lastly, from 2 to 4, can multiply by 2, and that pattern holds true all the way through. My first term is 2, and my common ratio is 2. Okay? Now we have this explicit formula, and the explicit formula looks like this. So I'm going to go ahead and highlight so we know. The explicit formula for a geometric sequence is the following. So you need to write that down or circle it. And we know from already doing this stuff that A1 is my first term. We know that R is our common ratio. And we know that N represents the number of terms in our sequence. Okay, so this first example here says, what is the 10th term of this geometric sequence? So first thing we're going to look at is, what is our R? So I'm noticing that my R is 3. Okay, so I'm going to use this explicit formula here. This A of n is equal to A of 1 times R raised to the n minus 1. And I'm trying to find this 10th term. So I'm trying to find A of 10. My A of 1 is 4. My R is 3. And the number of terms that I'm wanting are 10 terms. So I'm doing 10 minus 1. So I would do, and remember, order of operations, make sure you do this first. So 3 to the 9th on your calculator and then times 4 would be 78,732. So my 10th term in that sequence would be that. Okay? Now we're looking at what are the second and the third terms of this geometric sequence. Okay? So we know that this is my first term here that they've given us. So let's just go ahead and write that explicit formula. Times R to the n minus 1. And what we don't know is we don't know what our R is at this point. And but we do know this term. And that would be here's my first term, second term, third term. There's my fourth term. So I know if I do this for the fourth term, right? I know that my fourth term is negative 54. I know that my first term is 2. I don't know my R. And I know I'm talking about my fourth term, so I'm plugging in 4 for my n, right? So we're trying to figure out what this R is based on this information they've given us. So if I know one of my, or two of my terms, I can plug those in to find this R, okay? And then we're gonna solve. So this becomes a 3. I'm gonna write this over here. So negative 54 is equal to 2 times R cubed. Then I'm going to divide by 2. Oh, where'd that go? Let's try that again. Oh. Let's see. I can't see. There we go. Okay. So then I'm going to divide by 2 on both sides. So negative 27 is equal to r cubed. And then when I cube root that on both sides, r would equal, oh, sorry guys, it's not showing up on my iPad. R would equal negative 3. So now I can go back up here. R would be multiplying by negative 3. So this term would be negative 6 multiplied by negative 3, and this term would be 18. And so there are my two answers. My second term is negative 6, and my third term is positive 18. And they're my answers. Whoops. Why are you not showing up? Oh my heavens. 18. Okay, guys, this is supposed to be an 8, but it will not, for some reason, show an 8. I don't know why. It just doesn't want to stay. I don't know, but that's supposed to be an 18, just so we're all clear, okay? Oh, there it stayed, good. Okay. All right, so let's look at this next example here. So this one says, let's erase this. When a ball bounces, the heights of the consecutive bounces form, here's a keyword phrase, geometric sequence. If the ball bounces 100 centimeters on its first bounce and 49 centimeters on its third bounce, what will the heights of the fourth and fifth bounces be? All right, so we know that our first term or first bounce is 100, and we know that our third bounce is 49. The question is, what's the fourth bounce and what's the fifth bounce? Okay, we don't know our r, so that's how we're going to start like we did up above. We're going to find r first. So if I know my third one, okay, then I can plug in information. I know my third term, so that's why I'm putting a 3 right there for my n. And then I'm going to plug in what I know. I know my third was 49. I know my a of 1 was 100. And then I have r squared. We're going to divide by 100. And I'm going to leave this, right? We want to leave it. You see, we have an r squared, and we're doing that because when we square root, those are perfect squares. So we're going to leave that. R equals 7 over 10. So now, since I know my r, I'm taking this times 7 over 10. And then I'm going to take that number times 7 over 10. Okay? So you're going to get, when you take 49 times 7 tenths, 34.3. And then when you take 34.3 times 7 tenths, you're going to get 24.01. And I'll label that with centimeters. And that would be the height of my fourth and fifth bounce. Okay. Now, we talked about, on this next page here, we talked about an arithmetic mean. And this time we're going to look at a geometric mean. So you can find a single missing term by doing the geometric mean. So in a geometric sequence, the square of one term is equal to the product of its two surrounding terms. So essentially we're saying this: to find the geometric mean of two numbers, you're going to do the square root of x times y. Okay? So here's an example. So what are the possible missing values in the following geometric sequence? So this is a geometric sequence. So what I do is I multiply them together, and then I'm going to square root. So that would be the square root of 144, which is 12. Okay, so this number here would be a 12. Now, it could also be negative 12. You could have either option, because if I took this times 1/4, I'd get a positive 12. But if it was negative 1/4, I'd get a negative 12. And that works, right? If I take negative 12 times negative 1/4, I would get out a positive 3. So your answers sometimes can be positive or negative, okay? Now, if I go over here, notice that this is a positive number and this is a negative. The only way I go from positive to negative is by multiplying by a negative number. Okay, so, and again, the only way to go from here to a positive is multiplying by a negative number. So I know I'm going to have to be multiplying by a negative, which means this answer is just going to be a negative. All right, so let's look at this. So I'm going to look between these two. 1.2 times 4.8, and I'm going to take the square root of that. Okay? And the square root of 5.76 would be a 2.4. Sorry, what am I doing? 2.4. So this answer is going to be, and then it has to be negative. That's the only way it makes sense. Here's a positive. That's going to be a negative if that's a positive, and we know that because this one was negative. So negative 2.4 would be my answer. Okay? All right. Now let's move on from, we've been doing explicit formulas, and now we're going to look at series. So a geometric series is a series whose terms make a geometric sequence. How do you know if it's a geometric series? Has to have a common ratio, okay? And if you're looking at the summation notation, you just need to check to see if the explicit formula has an n in the exponent. If so, the series is geometric. So if n is in the exponent, we know it's a geometric series. And here is how you find the geometric series right here. Okay, so the sum of n of those terms is your a1, your first term, times 1 minus common ratio raised to the number of terms, all over 1 minus r. All right, so let's do some examples of this. Okay, so here is my first example. And we're supposed to find the sum of this series. Okay, so the first thing I need to do is find how many terms are in this. So let's just look here. I know that I would multiply by 2, right? So I know my r is equal to 2. But I need to figure out how many terms are here, because I don't know just by looking. So we're going to use that explicit formula. So a of n is equal to a of 1 times r to the n minus 1. And I know my first term is 3. I know that my r is 2. And I don't know how many terms, right? But I do know my very last term. So I'm going to put that in, my very, very last term, okay? And then I'm going to solve this. So I'm going to divide by 3 on both sides. And that would be 1,024 equals 2 to the n minus 1. Now, I'm wondering if you guys remember this. Back when you're solving exponentials, you have two options. You either get your bases to match, or you can common log both sides. So if I log both sides, Then remember, I can take my exponent, I can move it out front. So this is going to become n minus 1 times the log of 2. And remember, log of 2 represents a number. So we're going to divide by log of 2. And you'd want to do that in parentheses, okay? And when you do this, the log of 1024 divided by the log of 2 is a 10. And that would be equal to n minus 1, and then you're going to add 1. So this has 11 terms, okay? 11 terms. So now we're going to use our sum formula, which looks like this. And here we go. We're finding the sum of all 11 terms. My first term is 3. My R is 2. There were 11 terms, all over 1 minus 2, okay? And then you're going to do that. So you're going to do 2 to the 11th and do 1 minus that times 3, and then you're dividing by negative 1, and you should get out 6,141. So get your calculators ready. Okay? All right, so let's go over here to example 10. So on example 10, I notice I would be multiplying by negative 2. And that works. So I know that my R is negative 2. Okay? So let's find our number of terms first. So I'm doing, again, that explicit formula. A of n equals A of 1 times R to the n minus 1. I know my first term is negative 15. I know my R is negative 2. And I don't know how many terms I have, but I do know my last term is 480. All right, we're going to divide by negative 15. And I would get negative 2 to the n minus 1 equals negative 32. Okay. Now, you can't log a negative number, but remember the other option is, can I make a 2 and a 32 have the same base? Well, yeah, 32 can go down to a base of 2, right? 5 times. So I have this, keep that negative 2 there. So then I can drop those bases and set the exponents equal to each other. So the number of terms I have are 6 terms. So now I'm doing a sum of 6 terms. So I do my first term, negative 15, times the quantity 1 minus my R is negative 2, to the, I'm doing 6 terms, over 1 minus my R is negative 2. Okay? And you want to make sure that you do this first. So if you're plugging this whole thing in your calculator, you have to have parentheses around this negative 2. So you're doing negative 2 to the 6th power, and then 1 minus that. So you should be getting in here, let me just rewrite this down here. Should look like this, negative 15 times negative 63 over 3. So be sure that that's what you're getting on your calculator. And the sum of those 6 terms is 315. Okay? All right. Now, let's look at our next one here. So this time, it's being written differently. So we're writing it in the summation notation, okay? And I know that it's geometric because that n is in the exponent. So I know I'm doing a geometric sequence here. And then to find the number of terms, remember when it's written like this, you always just do top minus bottom and then add 1. So 7 minus 1 plus 1, it's just, there's 7 terms. Okay, so I know that there's 7 terms, which if you start at term 1, the number of terms is always your top number. All right, so we're finding the sum of 7 terms. Now, here's what you need to know. Remember, this explicit formula, there's information in here that we have to know. So number 1, the explicit formula. Remember that you're going to have to find your first term, which we'll do, and then whatever is raised to that n, that is your r. That's a given. Okay, so let's go over here and find, let's go down here and find our first term of this. So all I'm doing is taking 1 and plugging it into my n. And when I do that, a half to the 1 is a half, and 4 times a half is 2. So my first term is 2, and then I'm doing 1 minus my r is a half, raised to this, we're doing 7 terms, all over 1 minus my r, which is a half. And when you do that on your calculator, you should get out 3.97. Okay? Now let's try this one. So again, I know that it's geometric because there's an exponent of n. And I know this is my r. Now let's start off and find the number of terms. This time, we are not starting at the first term, so I can't just look at the top number and say 10 terms. It doesn't work like that. So I have to do top minus bottom and then add 1. And so this time, I have 7 terms that we're wanting to find. The sum of 7 terms, okay? So same as last time. So the sum of 7 terms. Now I need to know what is my first term. Well, remember, my first one we're starting with adding is our fourth. So I need to find what that fourth term is. So I'm going to do that by plugging in 4 in for my n. And so when I do that, I get out negative 40. So that's going to go right here. And then 1 minus my r is negative 2. Raised to the 7th, all over 1 minus negative 2. When you do that on your calculator, the sum is negative 1,720. Okay? Okay, we have 2 examples left. We're going to look at a word problem. Okay, so this says, a famous story involves a soldier who saves his king during battle. So to reward the soldier, the king offers him any prize within reason from the riches of the kingdom. The soldier requests a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat, let's just underline this. So single kernel of wheat on the first square, 2 kernels of wheat on the second square, 4 kernels of wheat on the third square, 8 kernels of wheat on the fourth square, and so on, until every square on the chessboard is occupied. Then the soldier requests that the king pay him an equivalent amount of money as how many kernels are on the 64th square of the chessboard. The king immediately states that their request is reasonable. How much does the king owe the soldier? Okay, so let's just look at this. On the first square was 1 kernel. On the second square, 2 kernels. On the third square, 4 kernels. On the fourth square, 8 kernels, right? He's going to pay him whatever's on the 64th square, however many kernels. So if we're looking at this, what's happening? I'm multiplying by 2. So this is an example of a geometric sequence where my r is 2, right? So we want to find this. What is happening on that 64th square? So I'm using my explicit formula. Remember what that is? Looks like this. Okay, so My first term is 1. My R is 2. And I'm plugging in that 64 for my N. Okay, when you do this, you're going to get, it's going to put it, your calculator will put it into scientific notation for you because it's humongous. So this is how much the king would have to pay that soldier. A humongous amount. All right. All right, so let's look now at this last example. So here's maybe what we have. All right. So it says, to save money for a vacation, you set aside $100. Each month thereafter, you set aside 10% more than you did the previous month. How much money will you have saved at the end of 12 months? Okay, so the first month I set aside $100, right? The second month, I save, each month thereafter, you set aside 10% more than you did the previous month. So if you take 100, let's just do this over here. If I take 100 times 10%, I would get out 10, right? Okay. Now I want my second month, I'm going to add 10 to this. So I know my second month I did 110. So that means I'm not just multiplying by 0.10, I'm multiplying by 1.1 because I want to add that 10%. So the third month, if I did that, would be 121. And the question is, after 12 months, if I add all this up, how much will I have saved? So we're doing sum, right? Sum after 12 months. My first month was 100. My R is 1.10 and then to the 12 months. And when you do that on your calculator, you would have saved up $2,138.43. Seems like a great saving method. Okay? If you have any questions, let me know.